Once upon a time, physicists thought they had a good grasp of how the universe works. Isaac Newton's laws of motion seemed to have established a firm foundation. What remained was to figure out the details. But in the early 20th century, Albert Einstein changed all that with his explosive theories of special and general relativity. Then in the 1920s came quantum mechanics, complicating matters further. Ever since, we've been struggling to reconcile general relativity with what we know about the quantum world. This is Unveiled, and today we're answering the extraordinary question, can science solve the God equation? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. In 2021, physicist, futurist, and popular science author Michio Kaku published a book called The God Equation, in which he chronicles the long, strange, and colorful history of the scientist's search for a theory of everything. The God equation is certainly a more evocative name for such a theory, conveying its potential complexity, universality, and just how fundamental it would become to every discipline in modern science. This alternate name for the theory of everything is a testament to how all-encompassing it would be if it were proven legitimate. And it wouldn't just revolutionize the field of physics. A theory of everything would be immensely impactful on all other fields of science as well. Chemistry and biology both work alongside physics, and in many ways, modern physics is also the basis for these disciplines. Chemistry in particular requires a comprehensive understanding of atoms and the way subatomic particles interact in the process that creates molecules, as well as an ability to predict how different elements and molecules will interact with each other. You can't understand atoms without physics, and if you don't understand elements and molecules, you can't really do biology either, as molecules are vitally important to all kinds of biological functions. Photosynthesis, for example. While a theory of everything wouldn't collapse all of these disciplines into a single unified field, it would have far-reaching implications for all of them. It's become the holy grail for modern physicists, and with good reason. But putting such a theory together has proven to be no easy feat. At the heart of the matter are the universe's four fundamental forces: the strong nuclear force, weak nuclear force, electromagnetic force, and gravity. They're called fundamental because they don't seem to be reducible to any other more basic interactions. A theory of everything would marry the standard model of physics, which incorporates quantum physics and describes the fundamental forces besides gravity, with the general theory of relativity, which deals with gravity. As important as both are to physics, these theories haven't yet been reconciled, and contradictions arise when we try to combine them. There must be some sinew connecting them for the universe to function so harmoniously, but we don't know what that connection is. Ultimately, what we need to bring them together is a theory of quantum gravity. Such a theory would be able to explain, well, everything. How matter exists, how the universe came to be, how every facet of reality, from the smallest quarks and leptons to the vastest ultramassive black holes, neutron stars, and even the Big Bang function. It's truly impossible to overstate the importance of such a theory and why scientists have spent an entire century since general relativity trying to develop it. One intermediate step towards creating a theory of everything would be to establish what's called a grand unified theory. Commonly abbreviated to GUT, a grand unified theory is a model aiming to show that the three fundamental forces besides gravity become one single unified force at extremely high energies. It's not just an idle fantasy driven by a desire for elegance and simplicity. There's actually experimental evidence backing the idea. At high enough energies, the electromagnetic and weak nuclear forces do unify into what's called an electro-weak force. The hope is that we can one day show that the strong nuclear force unifies with the electro-weak force into a single electronuclear interaction. If we could go even further and show that gravity unifies with the other forces too, well, we'd have the foundation for our theory of everything. If anyone ever figured out how this could be, it would be a eureka moment unprecedented in the history of science. Another promising attempt to create a theory of everything comes from string theory, and this is an idea that Michio Kaku focuses on a lot in the God equation. String theory has long been a particularly infamous area of physics, an apparently unnecessarily complicated way to re-explain the fundamentals of the universe. Instead of imagining particles as separate points in space-time, a method which has consistently worked well for scientists despite not being entirely accurate, string theory says that particles actually exist on a line or string. Each string is able to create different particles by vibrating in different ways. This sounds downright bizarre to most people, but the thing is that string theory, weird as it is, does incorporate gravity. This means that we've had a theory that explains the universe and unifies the three fundamental forces in the Standard Model with gravity for decades now, since roughly the 1980s. So what's the problem? Why are we still looking for the elusive theory of everything? Well, string theory has a glaring issue. It only works in a universe with more than 4 dimensions. In fact, superstring theories often pose a total of 10. As far as we know, our universe only has 4. 3 spatial dimensions and 1 temporal. So where are the other 6? Well, either we live in a 10-dimensional universe but we're incapable of perceiving these extra dimensions, or string theory is just plain wrong. Mind you, that wouldn't mean that string theory isn't valuable. In fact, while our current evidence outside of string theory suggests we do live in a 4-dimensional universe, it's still a significant step towards developing a complete theory, opening our eyes to new ways of looking at the universe. It's also morphed into M-theory, an even wider idea that says we live in an 11-dimensional universe. M-theory aims to unify not just the Standard Model and relativity, but also all of the competing versions of string theory. But is a theory of everything really necessary or even possible? Some have gone as far as to argue that we don't really need one, or even that formulating such a theory might not ever be possible, no matter how creative our thinking and how many experiments we run. The fact is that in isolation, the theories of relativity and the Standard Model work very well at explaining all kinds of things in the universe. Could it be that the universe is just too complicated for us to reconcile these theories into a single set of rules? There's also the possibility that, like Kaku's new name would suggest, there is a divine creator responsible for all of the intricacies of space-time and the physical world. If that's the case, would it even be possible for us to fully understand how the universe functions? Then again, perhaps the universe's incomprehensible scale and complexity are too much for a human brain to ever understand, whether or not there's a God. However, for now at least, there's no really compelling reason to give up. The greatest scientific minds of the past century have, to varying degrees, believed in such a theory. It's so ubiquitous among physicists that The Theory of Everything became the name of a blockbuster Stephen Hawking biopic, which also addressed Hawking's pursuit of such a theory. It seems strange to imagine that if we've already got the Standard Model, including the highly tricky rules behind quantum mechanics, and Einstein's theories of gravity and the physical nature of spacetime, that there's no way to tangibly unite the two theories. They're already extremely complicated areas of science, with physics in particular being noted for its difficulty for decades. So how much harder can it really be to come up with a single unifying theory? It's easy to imagine that someday we're destined to come up with such a theory, just like the apple falling on Newton's head. It simply might be the case that the rate of scientific discoveries is slowing down after it moved at breakneck speed for the entire 20th century. After all, we have tens of thousands of years of human history and innovation behind us, but only a century since Einstein's work was published. Work we're still trying to unravel in many other ways to this day. There's no way to know for sure what the future will hold, but if humanity's past achievements are anything to go by, we have every reason to believe that someday we'll be able to come up with a grand, unifying, beautiful theory of everything. And that's the answer to whether or not science can solve the God equation. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.